Okay, so what we will now do is we will try to get into the most basic and the most commonly used technique which is used for predictive analytics, and that is using regression models. There are other predictive analytics tools which you will learn through the course of the program, but regression model is the one which you are probably going to use most frequently. There are various categories of regression model. We'll start with the most simple one, the linear regression models, and gradually we will go on to the non-linear regression models. So the first question we need to ask is, why do we need regression models? Predictive modeling. So what do we understand by predictive modeling? That in various cases you want to you want to say that what is going to happen in the future, and that you can do only when you understand what is happening right now. So there will be a variable of interest which you want to predict, and there are various kinds of examples which we can think of predictive modeling. We will build on those examples as we go along, and our main objective is, will we be able to say that tomorrow or the day after or next year, this is going to be the possible values of a particular outcome we are interested in. Okay. So to get into predictive models, I have to find out which are the factors that explain our variable of interest. Okay. So that's the first key thing which we want to do. And then we need to find out that what is the relationship or the difference between regression and correlation. So why are these three important? For predictive modeling, to predict any values of y, we need to find out the set of values of x, which we think are going to explain how y moves. Now this could have also been done by correlation, when we look at only y and a single x. But as I say, a single x, which means when we are looking at correlation, we are looking at a binary relationship, that how is y moving with x. But what we will be faced with is, how is y related to multiple values of x? And in that case, we will not be able to do correlation. In fact, what we should be able to say in those cases is, how is that a particular variable x1 affects y when all other variables are held at the same level. So we are only interested in one variable affecting y when all other variables are kept at the same level. What are the possible examples which we can think of predictive modeling? So example 1. What do we think will be India's energy consumption as GDP grows by 6.5%? Now, if we were to answer this question, we need to first find out that what are the factors that affect India's energy consumption. Well, GDP growth rate is certainly going to be one, because higher the GDP growth rate, which means more people will be better off. They would probably consume more energy. More industries will be in place. It is because more industries are in place, the GDP growth rate has gone up. And because more industries are in place, the energy consumptions will go up. So there could be multiple factors. Now we need to be able to pinpoint those factors, find out which factors are important and which factors are not, and then try to make a prediction that if one of those factors happens to be GDP growth rate, and if that grows up to 6.5% next year, what would be the India's energy consumption. Second example, this is an example which you will probably very frequently counter in analytics exercise, that what is the default probability. In this case, we are looking at default probability of a customer who will default on a housing loan. Now again, what are the possible factors? The possible factors is the customer's income has gone down, or it is possible that he has a sudden liquidity shock, he needs some more money which he doesn't have right now, or his health has broken down, or there could be various other factors because of which a customer is unable to pay on the housing loan commitment. So therefore, we may be interested in what is the probability that a customer will default on housing loans. We will try and see how does one do such kind of predictive modeling. The third example is, how many fatal road accidents will we have in Delhi if the traffic volume increases by 10%? Okay. So first of all, why is this problem interesting? It could be of tremendous interest to insurance companies, because in the event of a fatal accident, all those people who are insured by the insured company has to make a payout, and they might want to recalculate the entire premium value and the actuarials based on this fact of how much they think the fatal accident is going to increase next year in Delhi. Given that we expect the traffic volume to increase by a particular percentage. So these three are only some of the indicative examples which we have put through. There are various examples of regressions which we will go along, which we will try to do as we go along this course.